Now let's move on to problem number 9, which is the integral of x raised to 7 all over integral of x raised to 4 plus 1 dx. So in order to solve this problem, we will use u substitution, wherein we let u is equal to x raised to 4 plus 1, du is equal to 4x cubed dx, and dx is equal to 1 all over 4x cubed du, or du all over 4x cubed. And x raised to 4 is equal to u minus 1 as we base in this equation, which is u is equal to x raised to 4 plus 1. So now applying it and by substitution, we now have the equation, the integral of x cubed times u minus 1 all over square root of u du all over 4x cubed. We can now cancel out x cubed, and it will have now the equation 1 all over 4 integral of u minus 1 all over square root of u du. So we move out the 1/4 away from the integral, as it is a constant value. So we can now separate this one. We can now separate this into u all over square root of u minus 1 all over square root of u. So now the equation will be 1/4 of the integral of u all over square root of u, or it is equivalent to u all of square or raised to 1/2 minus integral of 1 all over square root of u du. By power rule of integration, we will now have 1/4 times 2u raised to 3/2 all over 3 minus 2 square root of u plus the arbitrary constant c. So 1/4 times x raised to 4 plus 1, which is the value of u, we substitute it already, all over 3 minus 2 square root of x raised to 4 plus 1 plus c. So now distributing the c, the equation will be now square root of x raised to 4 plus 1 cube all over 6 minus square root of x raised to 4 plus 1 all over 2 plus c. So we can simplify this by getting the LCD. The equation will be now x plus 1 square root of x raised to 4 plus 1. This is also equal to x raised to 4 plus 1 cube minus 3 square root of x raised to 4 plus 1. By simply factoring it out, we will have this square root of x raised to 4 plus 1 times x raised to 4 plus 1 minus 3 all over 6. And by solving this, we will now have the final answer, x raised to 4 minus 2 times square root of x raised to 4 plus 1 all over 6 plus the arbitrary constant.